Blockchain Show is a podcast that demystifies cryptocurrencies and distributed ledger technology.
Hello, thanks for tuning in. This is the Blockchain Show. It's episode 231. We've got Jim Dolbear. I hope I'm saying your name right. I didn't even ask.
No, that is the correct way. Well,
okay.
That's the way I say it. My grandmother says it a different way, but
I'm sorry I stepped all over your intro. Maybe if you wouldn't mind introducing yourself a little bit more to the audience.
No problem. So, so I'm wearing an XX Network T-shirt because I'm one of the co-founders of the XX Network, and the XX Network is a layer one blockchain, and it's distinctive in a couple of ways. It's fast, it's scalable, it uses quantum resistant crypto, and probably that's one of the big distinctions. And the other is that it has its own privacy protecting layer, and I could explain exactly how that works. So it's a platform that allows developers to deliver dApps that are secure and private, basically. And but the XX Network is run by an on-chain council. It went mainnet in November of last year. There's the XX Foundation, which is a Cayman foundation company with an independent board of directors that supports it. And so, we started in 2017, and I left. I'm not a part of the foundation, and I'm not on the council. I work in the United States. I'm sitting in Los Angeles with Elixxer, and Elixxer is sort of like the featured lead dApp that's been developed on the XX Network, and it's at its core, it's a private messenger. And then we're adding a sort of suite of elective privacy features. So so by title, I guess I'm a co-founder of the XX Network, and but that's in the past. My job is I'm the chief strategy officer at Elixxer. And just by way of, I lived in LA for a while. I'm from Boston, but I met and married a woman from Los Angeles, and I met David Shawm. And we can get into a little bit who David is. David is a famous, accomplished cryptographer about 20 years ago. And we started working together originally on voting technology. And so that's, David is sort of the visionary and cryptographer behind the XX Network. And so that's how I got involved, what the connection was. And David also lives in Los Angeles.
Yeah, that's pretty cool. Voting's definitely one of those issues that ties in, I think it could, to blockchain technologies. Like I remember 4 or 5 years ago, I thought there should be, it should be really easy to just vote on the internet, securely. And there's problems with anonymity, and it's not quite that simple.
Yeah, so the reason David is the leading expert on secure voting technology. I don't think people really know that because he's known for having invented electronic cash, and did the first electronic payments in the early 90s with DigiCash. And also, but the reason that, and the first time he got sort of focused on voting was really in graduate school. Voting is the most difficult problem. If you look at sort of like applications of transactions or communications between two people. And the reason is this: it makes a lot of sense if you just think about, voting yourself. You're the voter. You want your vote to be counted. So you have to know that the person you give the vote to is the real person. Because if they're fake, your vote won't be counted, right? They need to know that you're a real voter. Right. So they need to confirm who they are. They need to confirm who you are, but you want your vote to be private because you don't want vote manipulation. You don't want, to vote one way and then have people find out about it, your employer, even your spouse or something, and have a political problem because of that. So it is a two-way anonymous. You have to confirm identities on both sides and confirm that the other person is who they say they are without knowing who they are. And this is basically the double-blind signature problem. And David addressed it in graduate school, and he chose voting because that was the most difficult part of it, because there's a issue with vote selling, which has to do with someone approaching you and getting you for money to vote a certain way before the vote takes place. But anyways, that's a sort of subtlety about, that's a subtle but critical challenge in voting. But the point, double-blind signature is also what makes a check digital cash. So like in a check, when you use a check, the other person needs to know that you are who you say you are and you have a bank account, because the check is not good unless it's backed by you and the bank. So there's checks don't work if you don't know who the other person is. So, but there are times when you don't want to use a check because you don't want the other person to know who you are. That's why people do, I guess, drug deals with cash, right? Yeah. So making cash, taking physical cash and turning it into digital cash is really like taking a check and putting a double-blind signature on it. So that what happens is they know that you really can back that cash, but they don't know who you are, and vice versa. It's very similar to voting, technically. So, yeah, David, just by way of history, David was very concerned about election confidence in the early 2000s, because there were emerging democracies around the world where they'd have a fair and free election. Like Jimmy Carter used to, former US president, dedicated his life, and Rosalind, his wife, who died recently, but they used to fly in with a group out of the Carter Center and witness elections. And then they would say, they had like a team of 100, and they would go to all the election spots and they would say, this is a, fair and free election. But then, because it was the first time people had voted, no one would believe it. So then they'd go back to killing each other, kind of tribalism or something. So David was like, this is a huge problem. If you don't have secure elections where you can authenticate and count the vote afterwards, you're going to have societies are going to have a hard time transitioning into democracy. And he was really concerned about that, because it's sort of a matter of life and death. So that's how I met him and we got started. And you're right, voting is a big deal. There's a follow-on voting project called VoteXX that runs on the XX network, which came out of that work, which is secure anonymous electronic voting. The problem with blockchain, generally speaking, is that there's a public ledger. There's pseudonymity, but there's a public ledger that can be tracked. So it's hard. You can't really vote on first generation blockchain. You can't vote on a blockchain. You need the privacy protecting layer that we have. So, yeah. And the reason for that, it's not just the reason that there was a public ledger in blockchain was not because they were stupid and said, hey, let's make things public when we could have things private. It's because the public ledger helped with the security. People could all check it. So it was a major feature of the security itself. And because delivering privacy is almost impossible. So, there wasn't a known solution at the time. So you get like, BTC, that it has an element of, the distributed ledger technology has a public ledger, and it's built in fundamentally to the system. And so, when you have a design like that, it's hard. You really can't vote because you can't meet the, anonymity challenges.
You mentioned that XX network has that, that added layer. Is that kind of like Monero? Because I know they kind of had like another layer to make it more anonymous than like just the regular.
Yeah, it's really not, and I'll explain why. And the way the internet works is really straightforward, in some sense. You have these packets, IP packets, and they are addressed with a public address on them. Sometimes I remember David at one of the conferences was talking about, it's a little bit like a bus. Like if you're sitting in a city and you see a bus, they have across the front where it's going. and what the stops are. So like everyone knows where that bus is going and everyone knows what the stops are. That's what the way the internet is designed. It's all public and it's all shared. So there's routers all over the world. They read those addresses and they send it to the right place, right? So the good news, it's a very robust, sort of easy to use addressing system to make sure packets get to the right place. That's why, if you send an email, it can find its way. And that's when you query a website and ask for a page or information, can find its way back to you. The problem is that means that all that traffic, so-called, the term of art is traffic, is public. So that means anyone, individual actors, governments, and government agencies, secret government agencies, and major corporations, they can track that traffic if they feel like it and think and have a reason to do it or want to do it. And this is the sort of problem. And people have just in the last 5 to 10 years, really in the last 2 years, realized the full extent of the problem. Facebook has been tracking your use of other apps to add to your profile on Facebook, which is pretty amazing. Meaning they're putting things in your Facebook advertising profile that have nothing to do with using Facebook apps or features. They're literally going out into the public trafficking information, collecting it, and adding it to your profile. And, the big kind of news with Ed Snowden, which I think everyone sort of knows, has heard a little bit about it, but, he was sitting in Hawaii as a sort of mid-level tech giving network access to CIA agents. And he realized that basically the CIA, and there's something called the Five Eyes, which is sort of, the Anglo countries plus France, people who won World War II. They basically tap the T3s, like the continents are connected with these T3s, which are like a T1. They're those fiber optics that run under the ocean. They tap them and they just pick up everything, all that IP addressing information and all the content. They call it the full take. So they take all that information and they stick it on huge databases. So and it's all public. So they can just do that. There's some laws that say they're not supposed to do certain things, but technically they can do, they can get all that information easily. So then this goes back. I mean, David had sort of foreseen this problem, and originally this was set up by really like the first really big decentralized organization was called the Internet Engineering Task Force. And the Internet Engineering Task Force, the words task force were carefully chosen. It was a legally informal, meaning there was no corporation. It didn't exist anywhere. It was just people around the world working together. And they had something called RTFs and RFCs, requests for comments. And they would put out a problem like, how are we going to know if someone wants to send something? How are we going to know where it should go? And people would say, we could do it like this. We could do it like that. And you can read up, there is an RFC about when they created URLs, when they created the IP addressing. And at the time, David had said, this is going to be trouble because all the traffic will be public. And the CIA, there's some guys who weighed in who kind of tilted it towards it being public. But once it got off on that track, once the internet was public like that, then this traffic information was available. So what the XX network does, and the privacy protecting layer that exists there, it's based on mixed network technology, which David first conceived of in the early 80s, like 82. And it's complicated, but not that complicated. It's relatively easy to understand. Basically, you have a sender, and so you have stuff coming in, and then you have just a series of servers, but you could think of them as like card dealers, in Las Vegas. The first one shuffles, it comes in, and everyone knows what order and who, and it shuffles it, and then it sends, and it shuffles and shuffles and shuffles. And so by the time it goes out the other end, no one knows how to connect, the sender and the receiver. And those shuffles are encrypted and decrypted, so you can't track it back through. And it's called a mixed network. It's sort of like a shuffle network. And in that way, you can destroy the connection between senders and receivers. You can destroy the traffic information. And so that was known in academia, as David, kind of described it. But the problem has always been that the shuffling and de-shuffling, the actual encryption, is a lot of math with big numbers. And so it was slow, wasn't really practical. And we stayed out of the whole, digital cash, blockchain, DLT space because we felt like privacy was critical. David used to, people would call him, because he was a famous cryptographer and invented digital cash. When BTC started to be known, people would call and say, hey, listen, you know a lot about Bitcoin. They use your stuff. Do you want to comment? And he used to refuse to take the interviews because it was clear to him this privacy issue was huge, and he didn't want to be all negative and kind of piss in the punch bowl or anything. So he would say, I prefer not to comment. And he also used to say to me privately, I don't know how to solve the problem. Bitcoin's going to be slow and public for a long time. I don't want to be a critic, and I don't know how to help. So we sort of stayed out of it. And this is sort of 2009, 10, 11 timeframe. And then he realized a way to accelerate this shuffling or mixing. And it's conceptually simple. Basically, he figured out how to securely set up all the encryption and decryption paths before they're used. So we call it pre-computation. So what happens in the XX network is teams of nodes do that shuffling beforehand, and then they wait. And then, when you send a message, you call on it goes to a team, and it goes flying through quite quickly in real time. So it's 3 orders of magnitude of the work is done beforehand. And so that means we can send a message in just a matter of seconds, just like a normal messenger, and send it through this privacy protecting layer. And you get the advantages of all the mixing without, the problems in terms of speed. So it's like a major breakthrough. It's hey, listen, we can send messages, and we can, on a blockchain with this privacy protecting layer, with this CMIX technology, and provide privacy to people on smartphones, and they can actually use it. Performance-wise, the latency will be effectively indistinguishable from an app that's out on the public internet revealing all its traffic. So that was a huge breakthrough. And there was an academic team that worked on it in 2015, and then a first paper was published, and they actually did a reference implementation and software. It was a team of academics from Europe and the United States. David was born in Los Angeles, but he lived for many years in the Netherlands. So he's kind of famous in Europe and has academic connections there. So it was 4 or 5 universities, and they published this paper. And then David decided, look, I think this really works. Let's commercially implement it. So the first, we all started working on it. I think the U.S. entity was formed in July 2017. And the first thing we did was the privacy protecting layer. So, and nobody else really has anything like that. Back to Monero, it does not use mixed networks. It's generally speaking, they use some sort of zero knowledge. Generally speaking, there's a category of platforms or chains that use zero knowledge proofs. And zero knowledge proofs is a way that a small group of computers can prove things and handle information without knowing what each other are doing. The problem is that zero knowledge proofs are pretty slow. So what you have to do is you have to give them to a small group of computers. And once you do that, then you've kind of defeated, as you know, in Bitcoin, there's hundreds and thousands of computers all checking on each other. Well, in zero knowledge proofs, there's a handful of computers that control the whole privacy. So basically what ends up happening is you end up getting off the decentralized chain into a small group of sort of semi-centrally controlled computers. And, it's easy. You have to trust them.
Mm-hmm.
So with us, the privacy is integrated into the entire chain. The consensus mechanism controls who's in the mix. It really is like a decentralized blockchain. So it's fundamentally different in the sense that it uses a mixed network, and that the nodes that run CMIX are part of a decentralized blockchain run by a consensus protocol. So
yeah, that's excellent. Monero probably wasn't the best example to bring up as just the first one. It does. Yeah. When you're talking about the nodes on the XX network, it does sound much more decentralized. But what's the method of consensus?
So, we really do have kind of like two pieces that are integrated in the XX network. So I mentioned just a second ago, we started with the privacy protecting CMIX. So we had a group of engineers, working on that first. And then we had our lead cryptographer is Portuguese, and our lead blockchain guy is Portuguese too. So that's just a coincidence, but we ended up basically with visa problems. The cryptographer was here on an academic visa in the United States, and so we tried to get him, anyway, we tried to get him a lengthened visa and all this. And it turned out that the solution was to create an office in the Cayman Islands. Cayman Islands is 2 to 3 hours off of LA, time-wise, so it was manageable that way. And you can get work permits there. And so we basically said, we got to get this done. We're gonna open a Cayman Island office, and then the people who are non-U.S. people, which all the key people there, they can be there. And we had one U.S. guy, and he lives there now. So we started what we called the Praxis project, and that name has been is sort of history now, but we call it is the consensus solution for the XX network, XX consensus, and it's a nominated proof of stake blockchain. The consensus protocol is distinctive in a couple of ways. It uses a compact digital signature, and the way that the problem with consensus is the security comes from lots of computers agreeing to something, and the problem is simply that the more when a lot agree, it's more secure and harder to crack. The problem is you have to communicate among and between all of those computers, and you have to send heavy-duty digital signatures. And so there's literally a physical problem with how long it takes to send, and then how long it takes to confirm the signatures and share them, to decrypt them. So what we developed was and a lot of it has to do with the fact that for the signatures to be secure, they're just very large numbers. So it's a lot to send, and it's a lot to decode. So we developed a new thing, which is, it's basically like, I think of it as sort of like a progressive signature. We call them compact digital signatures, but the reason they're compact is that instead of doing what traditional people did, which is pairwise, they'd have one computer send the whole signature to the other computer, and then every pair sent the whole signature. We send a piece of the signature and a piece of the signature and a piece of the signature, and then we effectively build up. The consensus is kind of underpinned by a huge signature that's built up in pieces by the team of nodes, and that means that what's actually sent between any two is much smaller and easier to handle. So, and that means we can process a payment, again, like on a smartphone, in some acceptable period of time, a matter of seconds, less than 10 seconds. We've proven 3 and 4 seconds. And again, that's the point of that was, from the beginning, we got in a second wave, and we said, our contribution is going to have this be private and have it work on a smartphone. You can pick up the smartphone, you can send a message, you can send a payment. It's a matter of seconds. It feels like a centralized app in terms of its performance. But what you're getting is, it is in fact running on a decentralized network with hundreds of nodes all over the place, controlled by, you know, a consensus protocol. So that was our original vision, and that's what we, you know, it took us a number of years, right? Because mainnet was, let's see, you know, mainnet was almost 4.5 years after we started. So we did a lot of original work, you know, doing those two things. And we still, that's also the core. There's a, you know, a group of core developers who are the original developers who still live in Cayman, and they're part of the foundation operating group. And that's why the foundation company is in Cayman. It's an outgrowth of the Cayman blockchain team.
It's brilliant, actually. I know, like you mentioned earlier, that, you know, part of the reason Bitcoin was, you know, somewhat transparent was just to maybe inspire trust, so people could see, you know, things are going where it's supposed to be going.
No, it's a critical piece. They did it on purpose, and it was smart. It just was. There was a huge trade-off. Like when they did that, they got the security. That's the good news. They lost the privacy. That's the bad news.
Right. And I'm curious. So you mentioned the nodes are all over the place. What's most fascinating, like incentivizing people to, you know, give up their resources and electricity? It's like, how do you get that piece? How do you get,
you know, it's a mystery to me on some level, in the sense that there are people running nodes in 70 countries. I've been to a bunch of them. I've met, you know, I know some, but I don't live in those countries, and I don't know what the electrical costs are and what they're living. You know, you're right. Like, you have to stick your neck out. You know, I think in our case, our node operators are real people, and we thought everyone had like real people running nodes. It's a little naive. I mean, I think we're really distinctive. I don't think other chains have real people. Like, they're all the chain, you know, they're all running out of Germany or the United States or something, you know. But and you know, we have people who are like running a node out of their house and, you know, paying for the internet connection, and now they're getting coin rewards. And, you know, I hope there haven't been, you know, many relationships damaged. Like, people are like, we're spending, you know, fiat on this internet thing, and they're giving you these coins, and who knows what, you know, they go down, they go up. I mean, it's a real, you know, it's a real proposition to run a node. The amazing thing to me on some level is people run nodes because they really believe in the vision. They think there really is a problem. And I know that because they've stuck with us, you know, as time has gone by, you know. And so why do they believe in this vision? Like, who are they, you know? Well, you can profile, and this also explains why we have nodes in countries that other chains don't. If your privacy has been violated, if you live in a society where you have been surveilled, or where there's been a problem with, say, public records, you know, someone is, you know, the government has questioned whether you own your house. If you've been in hyperinflation, these are like existential problems for you. Like, and running a node and being part of something like the XX network is like, for many people, something that they need to do for themselves and for their country. If you live in the United States, you know, I read this article from this, it was a Medium piece, and it was a guy from Princeton. I don't know, you know, Princeton is sort of cartoonishly the most waspy white private school, you know, college in the country. Within the Ivy League, it's the most that way. So this guy went to Princeton, and then he was getting his master's degree at the London School of Economics, which he explained in the blog post. And he said, this blockchain stuff is ridiculous. Who needs this? I mean, then he went through the things that he does in his life. And he was right. He's like a white guy from Princeton living in the United States. And this was a while ago, so it was before kind of the recent political tensions in the United States. But his, you know, this is like 5 years ago. But his bottom line thing was like, this is ridiculous. No one even needs this. I mean, someone's going to surveil me, take my money, you know. And the irony of it was lost on him. He didn't understand that he didn't have that problem because he was a white guy from Princeton who lived in the United States. Oh yeah, and he's studying in London, So he probably wouldn't. I'm sure he's not running a node, because why would he? So it's that said, depending upon how things go in the United States, people are going to start running nodes pretty soon. Yeah, so I don't mean to sort of give a vague answer, but it's the people who really understand that democracy is fragile, and that personal privacy rights are fragile, and that politically organizing and being able to express yourself politically depends on privacy. The people who really have seen those problems believe this is really serious. And the weird thing, I mean, David saw this coming, but he did it as a computer scientist. That's his degree, and he did it coming out of like, what will the network look like? And he had some personal, experience. I guess he's Jewish, so he realizes. I think he's realized since he was a child that things can go south, and governments and armies can attack you and things. Where there's a lot of people in the United States who just don't realize how much that happens anymore. But anyways, I hope that answers the question in some way.
Yeah, it does. I think having
just like the whole abortion thing, irrespective of what you think about it, what your fundamental view is, the idea that people who are pregnant, that they'll be surveilled, their messages tracked by the state of Texas so they can get arrested, which is happening, is pretty wild. So there's a lot of people starting in Texas who are starting to they're like, wait a second, this is serious stuff. Like, if I'm talking to somebody about my pregnancy, I have to worry about the government arresting me and tracking my, I have to stay, I better be careful. So it's that's happening right now. So for better, for worse, it's happening.
It's alarming.
So you can't go out on the internet if you're in that situation, or you should be extremely careful.
Well, yeah, even I remember those stories about, Amazon or one of these online shopping services, discovered a man's daughter was pregnant before he did, and he was all offended. But, based on the things she was searching and shopping, they could easily sell that information to a government. I don't know, man. It's just
it's craziness. It's and I think just the one thing that that really helps with this to me is that the problem is it all went digital. So, like, here's an example. It's an analogy, sort of an analogy. When I was a kid, it cost a lot of money to make a telephone call. Like, when I was in college, I had a girlfriend who was a ways away, and I'd try and call her, and it was like, $2 a minute or something, right? So, okay, so that's the way it was. And at that time, there were no spam calls, during dinner or something, because it cost a lot of money, right? So it wasn't economically feasible to bother people or spam people. When the internet got set up and the digital network was so efficient, sending out thousands of emails cost almost nothing. And it was a sort of analogous to a phone call. So basically, what had not been a problem because of the limits of technology, it wasn't and so society didn't have to worry about it, became a problem just because of a technology development. And a similar thing is true in terms of communication. People used to meet face to face and talk about issues, and there wasn't the technology to surveil them. So all those conversations were private just by virtue of the fact that there was no way to make them unprivate. But when all of that activity moves on to a digital network, which has public addressing, it becomes relatively inexpensive to figure out everything that everyone's doing. So so, sometimes when you're talking about these surveillance concerns or privacy concerns, people think you're kind of like crazy. Like, what are you like? Why are you, like, what are you making such a big deal? Like what, although now I think most people understand there's an issue. What happened is the technology just developed, all these problems were created, and no one thought about it. No one said, is this a good idea? It just happened. So I think the right way to think about it is like, here we are. Like I kind of, like you got Zuckerberg at Facebook surveilling everybody, he just did that to make a lot of money. He didn't, I don't think he's as swift as some people think. He didn't see any of this coming. He just made an S-load of money and then more money, surveilling everybody. And here we are, and no one's sort of thinking about it, like what it would mean. And the point is that we, the people, should decide how we want to live, not have the technology determine how we live. So technology makes everything easy to surveil, and so we'll all be surveilled. That's not a good outcome, right? We should decide how we want to live and then live that way. And then we'll use the technology to achieve those goals. So, people should live and democracies should be the way they should be, and then we'll make the technology fit that. Not just have the technology just run wild and then whatever happens, happens. And this is there's a huge problem with AI here, right? Because as AI develops and quantum computing too, like you have no idea about profiling, because once we get, some of this AI stuff, once they get the AI stuff more worked out and get a little bit more computing power, it's going to be hellish. So, anyway, and the reason that David, is the visionary behind, the XX network is really as a graduate student, he was right of the age. The network technologies and network designs, people were figuring this stuff out in the 60s, 62 into the 60s. But it was a more academic thing. They were running at, very small networks, in Palo Alto, really. And then, but the ARPANET was happened in the 70s. The first distributed network out of the Defense Department. And so you could sort of start to see a big network coming. And so, David was in the late 70s, early 80s. He was like, well, and because, computer scientists, they realized like if there's 2 computers, there could be 4 computers. And if there's 4, there could be 8. Like, so David was just like, I don't know why there wouldn't be computers everywhere in the world. Like, I mean, it's going to happen. And so it was sort of obvious in some sense to a computer scientist, but he took it really seriously. He's like, I'm telling you, it's going to be computers everywhere. And with public addressing, everything will be known. He had that insight in the early 80s. And most people, they had to wait for it to happen to realize it was going to happen. But really, he was a computer scientist who understood that a network would grow rapidly at some point. And the other piece of it is it really didn't happen as, and I think people don't really sort of realize this, but, the internet existed and then the World Wide Web. The World Wide Web is the browser interface. And that was a Tim Berners-Lee thing. It was when there was an easy to use graphical user interface, point and click mouse, just like on, computers with the Mac interface that Microsoft stole with Windows. When it was command line stuff and people had to type, not that many people used it. So the internet was kind of an insider thing until like 1994. But then that's when the browser stuff came. And that's when it like, boom, it was only a matter of time. It went mass market. And then everything was known. That's sort of the progression.
Yeah.
So, so our view is, you need the XX network to provide privacy when you need it. And the internet does not do it. It's designed to not be private. And, all the blockchains are designed to not be private. So you need, kind of bottom up privacy protecting technology to give you that privacy when you need it. And that's what the XX network is.
Yeah, I love it. Man, this has been good. Do you have time for another few questions or do you got to get going?
Yeah, sure. What time is it? Yeah, I have like 10 minutes.
Okay. When you mentioned, quantum security, we haven't talked about that on this show for like 3 years. So I imagine it's come leaps and bounds since then. Do you want to comment on maybe some of the threats and solutions there?
Yeah, I mean, the issue is that you just think up really big numbers. Fundamentally, codes, all this stuff is just codes, and you have really long numbers that are random. And if you start doing something like the house address for where I live is 2040. I don't do this anymore, but I used to have passwords that were like 2040, 2040, right? My house repeated twice. That's not a random string of numbers. And it's a code that's relatively easy to crack, because if you get the first 2040s, for example, you're like, whoa, maybe you did it twice. So what you do is you have a long number where every single digit is truly random, and the bigger they get, because it becomes impossible to guess that number. That's sort of that's pretty much it, right? So, but the problem is, on the decoding side, the longer the number is, the slower it is, and the bigger the number is, the more numbers are being communicated. So with quantum computers, you have to have a really long number for a quantum computer not to be able to break it. So that means that's why those compact digital signatures are so important. You could retrofit Bitcoin, but it would be even from an operational standpoint, it's really hard to do. All the code and all the signatures are not, quantum resistant, and it would slow the thing down. Like Bitcoin's already slow. So the impending development of real quantum computing power is an existential threat to all the systems that are fundamentally developed and designed with ECDSA, the existing legacy crypto, because it's hard to redesign them, and if you don't, they're going to get cracked. And that goes for like websites too, and things like the pricing updates on Amazon or something, those are done using legacy crypto. So when quantum computing comes along, unless people fix that stuff, people will be changing the prices and buying stuff for a tenth of a cent and stuff like that. There's the whole digital infrastructure is built on this legacy crypto. So you have to take it seriously, and you have to develop quantum resistant signatures. And when you do that, it's a major software and crypto implementation. And that's why we did it. Sometimes we say we future-proofed it. That's why we started with that challenge. We're like, if we don't build this in now, it's going to fall apart, and it's going to be impossible to retrofit it. So we put in quantum resistant stuff from the beginning. In terms of when it's going to happen, not known, in the sense that two things. One, there is a challenge of developing the technology, and the other is, when it is developed, they're not going to tell you. So the Chinese government or the US government, when they develop quantum computers, they're not going to tell anybody. So you may not know. There's a huge amount of money going into it, and there've been some really big breakthroughs recently in physical optics, quantum computing. There's like 3 different ways to kind of implement it. The amount of money that's going into it is, basically every government is plowing money into it, and then every major, like Hanfroffer in Germany, all the Siemens, like every major corporation, and there's also venture capitalists, just plowing money into it. So it's going to happen. And some people say 3 years, some people say 10 years. The other thing that's really important to know, which we identified and addressed, is that I was talking about this whole full take thing, which is like all the messages that you've sent that are encrypted with the legacy ECDSA crypto are saved somewhere. So when they get to quantum computing, they can go back and read those. So it's not just like thinking about what you're doing and like, oh well, I'll deal with it later. The stuff, the documents you have, the messages you send, they'll be crackable. If you save them now, you can crack them sometime soon. So that's a feature of when you send a message over the XX Messenger, the Elixxer privacy dApp, those messages are encrypted with quantum resistant encryption, so that they're protected no one will ever be able to read them. So there's also, that's an important issue, this issue of sort of understanding that what I'm sending now can be read in the future if I don't send it over the XX network using Elixxer. But it's going to be a major thing in terms of this infrastructure challenge, and everyone's going to have to deal with it. The other piece of it is there's really good things about quantum computing too. Obviously, things like economic modeling, understanding how to have healthy economic growth, healthcare problems. So we spend a lot of time people sort of going, look out for quantum computing. They're going to steal your money, which is a real threat. But it's also an incredible thing. I mean, hopefully, again, maybe this is a good thing to sort of end on. But I mean, I hope that it is a technology which is managed so we get all the good things of quantum computing and the minimum of the bad things. So like lots of breakthroughs in healthcare and not too much AI surveillance. But to do that, we as humans, as societies and as governments, we're going to have to manage that, because there are incentives in society that are perverse, and we could end up with lots of surveillance and no breakthroughs in healthcare. The technology needs to be deployed and managed by people, not by the computers or by
That's a good outlook.
Yeah, no, it really is. So yeah. And but before we break, I hope maybe next time we're working on adding basically the Elixxer dApp, which runs on the XX network, is built on top of the XX Messenger, which is private communications. And we're adding channel features like Telegram into the XX Messenger, and then we're adding a bunch of features around the XX Messenger to add on to it, so that you have a easy to use privacy dApp called Elixxer, where there's a provision for shielded help, where you can get on Elixxer and you can communicate with healthcare professionals about things like that are sensitive, things like suicide or maybe an abortion or something like that. Anything that you need help that's potentially sensitive. So we're building out a series of specific application areas within Elixxer to give people the privacy that they need when they need it. So yeah, and the other thing that just a final thing is we used to talk about surveillance and people weren't they're like, and David, like back in the 80s and 90s, they're like, it's not that bad, right? The weird thing is that just in the last year, and I think, it's a matter of people getting sensitized to what's really going on. The numbers in all the studies, it's something like 75% of people think that privacy is the big issue for Web 3.0. So we used to feel a little lonely, and we're out like on a street corner, proselytizing, hey, privacy, what about surveillance? And people would look like us, like we're wackos. But I think there's a general awareness now. And so, we're trying to help deal with it, but we need privacy in Web 3.0. I think that's a sort of widely spread, widely held belief. Yeah, and I think, like you said, yeah, we should talk about privacy when we first started. I think that's why, like, we're all started realizing, like, shit, we better deal with this. This is an issue. So there's something in the water, or it's that time, or people starting to be really aware at a kind of mass market level about it.
Yeah.
So, so we should make some big progress in the upcoming years, I think, all of us, and I hope that the XX network, we're trying hard to kind of do our part. So.
Yeah, well, sounds good. Definitely let us know where can people go to get the apps and connect and
so
learn more.
You can the XX network website is xx.network, and on there's places where you can join if you want to follow social media, and there are links to download the XX Messenger. The Elixxer dApp is at elixxer.io. It's ELIXXIR.io. The XX was shared in everything we did, so it's ELIXXIR.io. And the XX Foundation is just at xxfoundation.org if you want to sort of see kind of like who's supporting the network broadly. But everything is available on the xx.network site in terms of links, so you can sort of find your way through. Yeah, we'd love to have, you know, people involved as developers. We're starting to hold events all over the world. We've got we're making a big push on explanatory videos, you know, in the 15 to 20 minute range to explain these issues. And we have really, you know, active groups on Twitter and Telegram and on Discord. So we'd love to, you know, get people involved. And, you know, we hope to kind of like continue to grow. So yeah, getting the word out is a big deal for us. So thanks for asking.
Awesome. Yeah. Well, I really enjoyed the conversation. I know it went fast. It's a good sign. You know, hopefully you'll come back sometime, you know.
No, it's great to meet.
More.
Yeah. I mean, I've heard of you, and it's great to talk and meet you for, you know, face to face. So thanks, Ethan.
Yeah, my pleasure. Thank you. Have a good rest of your day.
Yeah, you too. Talk to you.